So now we are going to see in Python examples 2 and 3 in the same video. Example 2 is actually a definition of a greater common divisor function. Greater common divisor. So you have here that we define a function called GCD of two variables n1 and n2. And we set GCD to 1, which is the initial GCD for every number. So all numbers can be divided by 1. And k equal to the possible GCD. And we say that while k is less or equal to n1, and we also have that k is less or equal to n2, we enter that loop. We carry the division of n1 by k and see if the remainder of it is null. And we do the same for this. If this divisor can divide both of them, then we increment the divisor that we have right here. So we find the greatest common divisor between these two integers. And once we finish, since we have updated the GCD with the newest value of k, if that loops work, so we return the value of the GCD. So k is also implemented whether this works or does not, because we need to work on every possible divisor that is less or equal to n1 and less or equal to n2. Now, once we have done this here is just a function. There is no main, so this cannot be run on its own. So here, if we open up the third one, as you can see, the third one will actually make use of this function. So from GCD function, we import the GCD definition function from the GCD file, and we are going to prompt the user to use two integers, and we are going to find the common divisor for these two integers. So keep in mind that if two, for example, numbers have no common divisor except one, it means they are co-prime. So they do not have to be prime numbers, but it means that there is nothing that can divide them except one. So we are going to try running this one right here. And keep in mind that we are going to have here a small error, because actually the file is named C6Ex2Ex3 GCD function, and we are importing from the GCD function. Now, if there are spaces, Python does not understand them very well. So here is what's going to happen. As you see, it tells me it has not found the function. If I write here instead of GCD function C6X2 space dash space GCD function, Python is not going to understand it either, because it does not understand the spaces very well. So what I'm going to do is that I'm going to take this, I'm going to control and paste it right here, and I'm going to rename this GCD function only. Okay, this is the only name I'm going to give it, GCD function. So now if I want to run the program once more, you see now it has understood that there is GCD function because it has the same name, okay? The same name. You do not need to add the .py. You simply have to put the name just before the .py. So now if you try the first integer, let's, for example, let's try 39, for example, okay? And let's try 13. So 39 is divided by 13. It's actually 3 times 13. So 39 and 13 have for greatest common divisor 13, okay? And you could try any couple of numbers you want. This helps you see, for example, if a ratio can be reduced to something more simple. So let's suppose you have at the numerator, for example, 521. And let's suppose you have at the denominator, for example, 74. So these two are co-prime. There is no common divisor between them other than 1. So you would not be able to reduce this fraction. But let's try it, for example, with 522 this time. And let's try it with 74. Well, this time these two can be divided by 2, so that works out. Okay, let's try also another couple just to have fun. Let's try, for example, 2 and 3. Well, of course, they are already prime and they are co-prime as well. So nothing as a common divisor except 1. So you see here what we have done. We have actually defined this GCD function alone. We are calling it in our program. Okay, we are calling the GCD function, and we are doing what we want to do. So this is as importing the turtle module. So the great thing about this is that you could, for example, code something for someone, and then they could just import the function as they call it from the module that you have defined, and they call the function that you have defined. You could do, for example, a function that calculates area for a triangle, for a parallelogram, etc. And then the user will have simply to input the values of the variable you have defined within your function, okay? And then the rest will be done by itself. So that's the beauty of defining it outside of your main function. And whenever you change it, you'll simply have nothing to change here, except if there are, for example, more variables, then you'll have to take that into consideration. But otherwise, there is nothing that you have to change. You can change it externally and then re-upload, for example, the updated file so that people can use it in an updated manner without having to change their own program. So that's the greatness of that modular way of programming. And now I'll see you for example number 4.